So again, it's coming down to having those identities and knowing which ones to use. The objective, I'll verify trig functions by working with one or both sides of the equation. So a reminder, your reciprocal identities are ones that are going to be used a lot, quotient identities, and your Pythagorean identities. And let's not forget our negative angle identities. So again, I'll use PI if I'm using a Pythagorean, QI if I'm using quotient, RI if I'm using reciprocal. So on this one here, perform each indicated operation and then simplify. So the first thing I would tell you to do would be to change everything to sine and cosine. Okay, so on that case, then if I multiply cosine with secant, change everything. This is still going to be cosine of beta times secant, that's a reciprocal identity, is 1 over cosine of beta plus, and cosecant is 1 over sine of beta. So to get to here, I used quotient identities. Okay, so next step is an algebra step. I'm going to distribute the cosine. So I have cosine of beta over cosine of beta. Remember, it's numerator with numerator, denominator with denominator, so I can also rewrite it as 1 over cosine over 1 plus, and then cosine times sine gives us cosine of beta over sine of beta. So this is an algebra step. I distributed. Okay, and then cosine over cosine is 1 plus, and cosine over sine is cotangent. And this would be the quotient identity. I just realized this was not the quotient identities up here. They were reciprocal identities. Okay, and this is our answer. Perform each indicated operation, simplify the results. There you go. Now, we could have multiplied through and then changed everything, but this is just as easy to change everything to sine and cosine first. Okay, so next one. Okay, very first thing we have to do here is get a common denominator. This is sine plus minus 1, sine plus 1. So we have to get a common denominator. So on this one here, what I'm going to do is I'm going to multiply this way. Then I'm going to multiply that up. I'm going to multiply this way, then I'll multiply this way, then I'll multiply this way. So 1 times sine will give us sine of, I'm going to use x, plus 1 minus, and then I multiplied this way. The minus sign came from here. Multiplied this way. So I get sine minus 1 all over, and then you multiply these two together. So sine of x minus 1 times sine of x plus 1. Again, all I did was get a common denominator. So yes, this is an algebra step. Common denominator. Okay, and next thing down, this one's going to be a two-step. It is algebra. Next one's still algebra, but I'm going to combine like terms on top. And on the bottom, I'm going to FOIL it out. So keep in mind at the same time here, I need to distribute this negative. So this guy becomes negative, this guy becomes positive. Sine minus sine is 0, 1 plus 1 is 2. So I get 2 over, and then FOIL this out. Sine times sine gives me sine squared. Sine times 1 plus sine of x, negative 1 times sine, negative sine of x, and negative 1 times positive 1 is negative 1. And this is where I get to point out this is a difference of squares. You need to be able to recognize these so you can do them fast. Everything is exactly the same. One's negative, one is positive. Because look what's going to happen here. These two guys cancel out. So we have 2 over sine squared of x minus 1. That was still another algebra step. Algebra. And all I did was clean it up. Clean up the denominator. Now we do have a Pythagorean identity, but we can't use it yet because the Pythagorean identity we have is 1 minus sine squared, but we can always factor out a negative sign, and that will give us what we want. So if I made this 2 times negative 1, then I would have 1 minus sine squared. Again, algebra step. Factor out a negative 1. Now we can use our identities. Pythagorean identity for the next step. 1 minus sine squared is cosine squared, so I have negative 2. All I did is bring the negative up over cosine squared. And now I can use a reciprocal identity. Cosine and secant are reciprocals, so this becomes negative 2 secant squared of x. And there's your answer. Okay, seems like a lot of steps, but a lot of these steps could have been done at the same time. Common denominator. I did actually do 2 steps here. Did these 2, but you can also clean this up if you recognize it's a difference of squares. You clean it up, and you don't have to worry about this. And still algebra. Got to clean up, factor out the negative 1, so I have 1 minus sine squared, or you could have simply said sine squared minus 1 is negative cosine squared. And we get all the way down to this. Okay, let's try our next one. Okay, 1 plus tangent of s squared. Again, I'm going to change my s to x. And guess what? The first step is an algebra step. You need to FOIL. And please, please, please remember that 1 plus tangent of x squared is 1 plus tangent times 1 plus tangent. Okay, so back to this one here. So I really have, I'm going to again change that to x. 1 plus tangent of x times 1 plus tangent of x minus 2 tangent of x. FOIL this out. 1 times 1 is 1. 1 times tangent x is plus tangent x. Tangent x times 1 plus tangent of x. And tangent times tangent gives me tangent squared of x minus 2 tangent of x. Okay, and that's this one here. Next step is we're going to combine like terms. So guess what? Another algebra step. Combine like terms. So I have 1. Tangent plus tangent gives me 2 tangent. Plus tangent squared. Minus 2 tangent of x. But guess what? Negative 2 and positive 2, bye-bye. So 1 plus tangent squared of x. Everything we did there, combine like terms. One step left, 1 plus tangent squared equals secant squared. And that is a Pythagorean identity. Those are going to be the easy ones to use because they're going to have squares on. You have to have a square to use a Pythagorean identity. Okay, next one. This one's just asking you to factor it out. So this is one of those a lot of times. I wouldn't change the trig function. A lot of times it's easier to do the algebra if it looks like algebra, and since they're only asking us to factor, I'm going to do this. Let x equal secant of theta. So if we rewrite this, we just have x squared minus 1. Now for those of you who have to do this, first and the last gives you -1. The middle term is 0. So factors of -1 that add up to 0, 1 and -1. So this is x plus 1, x minus 1. But remember, x is secant. So secant of theta plus 1, secant of theta minus 1. All they asked you to do is factor. They didn't ask you to do anything else. There you guys go. Okay, so this one here, factor again. So this one again might be a little bit easier if we rewrote these as x and y. I do want to point out that this is a difference of squares. How do I know? Sorry. Because I have tangent plus cotangent squared, minus tangent minus cotangent squared. So I have a value squared minus this value squared. I'm going to try and make this look easier. So I'm going to let x equal tangent of x, and I'm going to let y equal cotangent of x. So then I can rewrite this as x plus y squared minus x minus y squared. And again, I want to point out, this is a perfect square, this is a perfect square. So difference of squares, this is my a term, so I can write up here, that means a squared minus b squared equals a plus b times a minus b. That's my a, that's my b. So a plus b, so x plus y plus x minus y times x plus y minus x minus y. Okay, again, that is my A and that is my B. Okay, still all algebra. We have done nothing with trig. So on this one here, I am going to combine like terms within the parentheses. Combine like terms within parentheses. So x plus x gives me 2x, y minus y, that's it. Let's distribute that negative. This guy becomes negative and this guy becomes positive. So x minus x, 0, and y plus y is 2y. So I factored this all out and got 4x, y. But don't forget, x is tangent and y is cotangent. So 4 tangent of x, cotangent of x. Here's where our identities come in. Quotient identity. 4 tangent of x And cotangent, it's not quotient, reciprocal identity. And cotangent is the reciprocal of tangent, which gives me 1 over tangent of x. And these two cancel out, and we are left with 4. We did a lot of work to get 4. Okay, and the next one here, again, factor. So again, we're going to let x equal cotangent squared of x. So if I take a square off this, I'm going to be left with a squared. So x squared plus 3x plus 2. They said to factor this. So the a and c is 2. This is 3. I need factors of 2 that add up to 3. That's going to be 1 and 2. 1 plus 2 is 3. 1 times 2 is 2. So we get x plus 1, x plus 2. But don't forget, x equals cotangent. So this is cotangent squared of x plus 1. And this one is cotangent squared of x plus 2. And no, we can't do anything more to these guys. Okay, this one here is one that you probably haven't seen. So let's, a lot going on. This is a sum of cubes. Sum of cubes. So I'm going to do an easy one like x cubed plus 8. So this one here is obvious, x cubed plus 2 cubed. I consider this guy my first and this guy to be my last. So what we're doing, the formula, it's just a formula, is that it becomes first plus the last times the first one squared minus the first, okay, I'm just trying to squeeze things in. Okay, the first one squared minus the first times the last plus the last one squared. Now, it doesn't matter if this is plus or minus, because this is what we're going to use. This is where SOAP comes in, what I call SOAP. This one is the same as the original, S for same as the original. This one is O for opposite of the original. And then this one here is always positive. So not only use the first and last, but it doesn't matter if it's x cubed plus 8 or x cubed minus 8. If it's x cubed minus 8, this would be minus and that one would be plus. Same as the original, opposite the original, always positive. So once we're over here, all we have to figure out is what is my first and last. Well, first is going to be what's cubed, sine. I'm going to change the alpha to x. And my last is what's being, the last one being cubed, which is going to be cosine of x. And we grab our formula. So sine of x plus cosine of x times the first one squared, so sine squared, opposite, sine of x times cosine of x, always positive, the last one squared. And this is where I get to remind you guys that sine squared plus cosine squared, these two guys together, equal 1. Pythagorean identity. So I have sine of x plus cosine of x times 1 minus sine of x cosine of x. Again, getting here was using a Pythagorean identity. Everything else was algebra. And we are done with this one. Okay, the next one. So each expression simplified to a constant, a single function, or a power of a function. Use fundamental identities to simplify. Okay, first thing I'm going to show you guys is what I call funny factoring. Funny factoring. And actually, this is going to be the first step we're going to do, is I just take my fraction apart. So I'm going to write that with taking the fraction apart. So this gives me cosecant of theta over 1 times secant of theta over 1 times 1 over cotangent of theta. Okay, so I'm going to use a reciprocal identity. To get this guy into the numerator and to change these guys to sine and cosine. So the reciprocal of cosecant is sine, so I get 1 over sine. Reciprocal of secant is cosine, 1 over cosine. And reciprocal of cotangent is tangent. Now this is where I need to point out is notice that I changed cosecant to sine, so it became 1 over sine. Secant to cosine, so it became 1 over cosine. Cotangent, I changed the tangent, so it became tangent over 1. Please don't write it as 1 over tangent. That's making your life a lot more difficult. So let's get these guys down where they're supposed to be, because this is how we got there. Okay. Next one is going to be a quotient identity, and I'm going to change tangent to sine and cosine. So I now have 1 over sine times 1 over cosine times, and tangent is sine over cosine. Okay, and we're going to algebra step. We're going to reduce. So I have a sine in the numerator and denominator, so there. So I'm left with 1 over cosine squared of theta, and use a reciprocal identity to get to secant squared of theta. Now, this is where I get to tell you that, yes, you could have done these two steps together. You could have gone cosecant is 1 over sine, secant 1 over cosine, and go cotangent is 1 over cotangent is tangent, and tangent is sine over cosine. You could have, without writing this, you could have jumped straight to this step, but you still would have had to do the reducing. Okay. And so another one. So on this one here, same thing. What I'm going to do is I'm going to use a quotient identity to change this guy. So I have cotangent squared of x plus cotangent of x, tangent of x. I got here using a reciprocal identity. I'm going to use a reciprocal identity to cancel these two guys out. Remember, cotangent x equals 1 over tangent of x. So I really have cotangent of x times 1 over cotangent, or tangent times 1 over tangent. These two cancel out and are left with 1. And Pythagorean identity tells me that this guy here is cosecant squared. And we're done. That is also the end of the first video. I know it's long, but it is the end of the first video. And this is going to be your homework. So this is 5.2 part A homework. You are going to get hit twice with the homework on this section as well. Good luck.